Hello and welcome to another session on geometry and trigonometry. In this lesson we will be discussing the radian as a unit for measuring angles. In doing so, we will first define the radian, then we will learn how to convert angles from degrees to radians and vice versa. We will look at some of the advantages of working in radians. We also want to ask ourselves whether the only units that we can use for measuring angles is the degree or the radian. Is there another angle that we can use? Okay, so let's begin. So first of all, by description, we'll try to visualize the radian. So let's describe this. Consider a circle of center O and radius R as shown there. Okay, so that's the center O and radius R. And now what we're going to do is to measure out a radius of the circle. In other words, take that red length and we're going to map it out along the outline of the circle. So we will take that length and wrap it along the outline of the circle. So that's the radius there, and if we pull it out like that and map it out along the circumference of the circle like that, then the angle we end up with, what we end up with there is what we're going to use to define the radian. So if we let this side be, this point here be A on the circle and that be B, then the arc AB has a length that is equal to the radius of the circle. And so in that case, the angle that the arc AB subtends or forms at the center of the circle is what we refer to as the radian. So that would be 1 radian. So the angle you see at the center of the circle, which has been created or subtended or formed by an arc of length r, is called the radian. So 1 radian is the angle subtended at the center of a circle by an arc whose length is equal to the radius of the circle. Okay, so by definition, there it is. A radian measure is the angle in degrees that is subtended at the center of a circle by an arc equal in length to the radius of the circle. Now you can try this on one of graphing packages such as GeoGebra and so on, and try it out and try to measure that angle there. You should find that that angle is approximately 57.3. So to 7 decimal places, it is 57.2957791. It continues to infinity, since the radian is actually an irrational number, a special number just like pi or e and so on. Okay? So 1 radian is approximately 57.3 degrees. So this angle here will be approximately 57.3 degrees. So then the next question that must occupy our mind is, how many of these radians are there going around the whole circle? In other words, if I was to wrap a radius all around the circumference of the circle, how many of them am I going to get? All right, should be interesting to find this out. So there is my my circle again with radius r, and the angle at the center about 57.3 degrees. Now, how many radians? How many of these 57.295 whatever? How many are there around the circle? So if I have 360 degrees, how many 57.3s or 0.29 whatever can I get going around the circle like that? And of course, since the circle is 360 degrees in there, then to find the number of times this goes into the circle, I have to take 360 and divide by 57.29. And when we do that, we get 6. So it goes in around 6.2831 and so on times. All right? Let's look at that on the circle. It means that if I was to split the circle like that, I'm going to get 1, 2. So 1, 2, 3, 4, 5, 6. And there is a bit that is left there. And that bit is the 0.2831 and so on parts of a radius. Okay? And therefore we can say that 360 degrees contain 6.28 radiuses. Okay? Or better still, 360 degrees contains 6.28 radians as a unit of measuring an angle. Now 6.283185307, if I split that into 2, or if I could write it as twice another number, so I can write that as 2 into 3.141592654, and that also continues to infinity. This is an irrational number that should mean something to you, should be familiar. I'm hoping that you can already tell that that number is the familiar pi, which is to say, therefore, that we can write that there are 2 pi radians in 360 degrees. So an angle of 360 degrees is equivalent to or contains 2 pi radians, or 2 pi radiuses going all around. Okay? I hope this makes sense. Now we need to learn how to convert from degrees to radians. For example, how many radians are there in 50 degrees? So if 360 degrees contains 2 pi radians, or 6.28 radians, how many radians are there in 50 degrees? So to do that, we must think about our 360 degrees containing 2 pi radians. If we divided that by 2, both sides by 2, then we will get that 180 degrees contains pi radians. Okay? And that also means that if we divide this by 2, or divide that by 4, we'll get that 90 degrees contains pi over 2 radians, or we can say 180 degrees is equivalent to pi radians, 90 degrees is equivalent to pi over 2 radians, and so on. 60 degrees would be taking 180 and dividing by 3. So if we divide both sides by 3, we get that 60 degrees is equivalent to pi over 3 radians. 45 degrees can be found by taking 90 and dividing by 2, and that gives us pi over 4 radians. 30 degrees can be determined by taking this, dividing by 3, or taking 60 degrees and dividing by 2, and we find that it is pi over 6 radians. Okay? And in so doing, we can also reason that therefore 1 degree can be found by taking this equation and dividing by 180. So 1 degree is equivalent to pi over 180 altogether radians. And why is this important? It's because now we can use this to find any other angle. If somebody wanted to find the angle in radians, 20 degrees for example, 10 degrees, 50 degrees such as this one, then we just say if 1 degree is pi over 180, then 50 degrees must be what we have for 1 degree multiplied by 50, which is to say that 50 degrees is pi over 180 multiplied by 50. When you simplify that, you get 5 pi over 18 radians. So in general, if we have an angle in radians, if we have an angle in degrees and we want to convert it to radians, we take our angle in degrees and multiply by pi over 180, and we will get our angle in radians. Similarly, if we have an angle in radians and we wanted to convert it to degrees, then we take our angle in radians and multiply by 180 over pi. Okay, our answer is going to be in degrees. Right. So R there and D represent the radian and the degree respectively. Right. Is there another unit for measuring angles? Now, if you own a scientific calculator such as the TI and Spire, which I have here, then you may also have noticed another unit for measuring angles. If you look right there at the corner, we have your angles measured either in radians or in degrees. That means RAD. So it's written there either RAD or DEG for degree. But if you have ever gone to settings, you will find there is another symbol there which indicates that there is a third way of measuring angles, or a third unit for measuring angles. And so this is for those who own scientific calculators. TI-84 also has it. TI-83, 82 will have this. So this particular unit is called the gradian. So if you check your calculator settings, you will find the third one there is GRA, also called the gradian. And what is the gradian? This is not important for our program, but you may need to know it just for general knowledge. You probably wondered why there is another unit for measuring angles, and this is called the gradian. So what is the gradian? For general knowledge, the gradient can be defined. So first of all, let me just explain how to get to this. So if you own a TI Inspire, go to the home setting. Home is right there where you press the calculator on, and go to the settings on the left hand side, which is point number 5. Then go to document setting, and if you get there, you will have the area for angles. I'm showing you this now. So when you go in there, you will go to this, you'll get this screen here, and if you go to angles there, which is the second from the top, you will see there is radian there, there is degree, and there is also the gradient. So what is the gradient measure? So another way to see it is to go to the top, and if you click that, your calculator might be saying degrees now. If you click it, it will go to radians, and if you click that again, it takes you to gradient. So what does the gradient mean? So by definition, a gradient, and this is how we symbolize gradient, a gradient is the angle that is contained, is basically 360 divided by 400. So 400 of 360 is called a gradient. All right? So one gradient is found by taking 360 degrees and dividing by 400, which gives us 0.9. So one gradient is 0.9 degrees. We can also write a gradient in terms of radians. We can convert from gradients to radians. So because a gradient is 360 degrees divided by 400, then in radians we would have to take 2 pi, because 2 pi is the equivalence of 360. Okay, and so if we take 2 pi and divide by 400, we get that one gradient is pi over 200 radians. But this information I'm just giving you for personal knowledge. You do not need it for the IB diploma program. Okay, now why do we use the radian measure? We go back to our radian. Why do we use the radian? Why radian and not degrees? Well, the radian is a more natural unit for measuring angles. The degree comes from the Babylonian system of using base 60. We do not know why somebody chose to use base 60. We know, for example, we suspect that we use base 10 because we have 10 fingers, so 0, 1, 2 up to 9. So our base 10 is probably based on the fact that we have 10 fingers in our hand. So it's basically just our own choice to use a particular base system for numbers. Similarly, the base 60 was a number that was preferred by the Babylonians, and therefore it has no significant meaning or natural meaning to measurement of angles. The radians, on the other hand, is purely based on properties of the circle. That means how many times the radius of the circle goes around the circumference of the circle, or how many times the diameter of a circle can map out around the circumference of the circle, and this remains constant irrespective of the radius of the circle, irrespective of how big the circle is. And it is for this reason that the radian measure is probably better preferred compared to the degree. Another potential reason is that the radian has no unit. In fact, we say radians, but when we use it in calculation, there is no real unit to use there. So it does not influence other units in a calculation. Okay, just because it is a ratio of angles, it does not influence other units that might appear in the measurement. Point number 3, another reason why the radian is better. When we look for the arc length of a circle or the area of a sector, some of the formulas we use are L is r theta, where L is the length of the arc and theta is the angle at the center. So if I draw a circle such as this here, and we talk about A and B, the length there is related to theta there and related to the radius of the circle. So L is always equal to theta multiplied by r, this relationship is true if and only if this angle is measured in radians. The length of a circle is related to the angle and the radius if the angle is measured in radians, not if that angle is in degrees, okay? Similarly, if we wanted to find the area of the sector, we know that the area of that sector is going to be 1 over 2 r squared theta, or theta r squared. Once again, this theta has to be measured in radians in order for this formula to hold true. So those formulas only work if the angle is measured in radians. Right. So that is a third reason why the radian is in fact a better unit to use for measuring angles as opposed to the degree. A fourth reason is that in calculus and trigonometry, for example, some relations such as the limits hold true only in radians. For example, the limit as x tends to 0 of sine x over x or cos x over x. So when we write, for example, limit as x tends to 0 of sine x over x equals 1, this relationship only holds true if this angle x here is being measured in radians. All right, so these limits, whether it is on sine or cosine or tangent, they hold true when those angles are measured in radians. A fifth one, there are many reasons why the radian is a better unit of measurement, but a fifth reason here relates to HL students, power series, Maclaurin-Taylor series. If we expand sine using the Maclaurin-Taylor series, or cosine or tangent or anything else involving trigonometry, the power series or expansion, or the polynomial series expansion of sine, for example, when we write it like that, this continues to infinity. The polynomial expansion holds true only if the angle x there is being measured in radians and not in degrees, okay? Incidentally, you can see this is x power 1, x power 2, x power 3, x power 5. The next would be x power 7, and so on. You can see that the polynomial expansion is powers of odd powers of x, and this is one of the reasons why sine of x is an odd function. On the other hand, the cosine expansion is also given here. The next one is going to be x power 6 over 6 factorial, x power 8 over 8 factorial, and so on. And so you can see the powers are even, and this is another reason why the cosine is in fact an even function. All right. Here is, hopefully you understood, I'm hoping that you understood that. So let's look at some exercise on conversion from degrees to radians and vice versa. Convert each degree measure into radians and each radian measure into degrees. So I've put here 12 questions that I want you to try. So you pause each question and try it out. So negative pi over 6, I would like you to turn that into degrees, and negative 30, you should turn that into radians, and so on. So you will pause the video one at a time and try them out. And once you've completed all the 12 questions, I am putting the answer next. Okay, so those are 12 questions that I want you to try. And once you are done, then you can check the answers here. Okay, so these are the results of those angles converted from degrees to radians or from radians to degrees. This brings us to the end of this lesson. I'll meet you next to look at some special trigonometric angles. Thank you.